let's walk through a sample solution to the coding challenge in the previous lesson. First up, we had to define a flight struct with 4 fields. So right here, let's begin with our struct keyword, and the name of our struct is flight. And then I'll provide my curly braces, and in here we'll define our field names and their associated types. So we need an origin field set to a string, then a comma, and on the next line I'll declare my destination field, which will also be a string. Then the flight is also going to have a price, which will be a floating point value, so an F64. And finally, the number of passengers on the flight, which is always going to be a positive number, so I made this a U32. Derive a debug trait implementation for the flight struct. Sounds good. Directly above my definition, I'll provide my attribute, so my hashtag, then my pair of square brackets, and in here I give the compiler an additional directive, a command on how to parse the code below, and this one asks the compiler to create a debug trait implementation for this struct, which just uses the default debug representation of a struct, which includes its name as well as the fields and their values. So the command here is derive, and we specifically want to derive the debug trait, and that should do it. Next up, define a new constructor function that returns a new instance of a flight. So in order to define both methods and associated functions, we need to declare an impl block. So I'll use the impl keyword for implement, then the name of my type, which is flight, then a pair of curly braces, and in here I define my functions and methods. In order to have a constructor function, which is one that is not a method, but rather just a function that lives on the type, all I need to do is avoid the self keyword, and Rust will infer that type of function to be an associated function rather than a method. So I will follow the community convention of calling my constructor function new, although the name is technically up to us. And since I'm going to be writing 4 fields, I also need 4 parameters of the same type. So I'll declare an origin parameter set to a string, a destination parameter set to a string, a price parameter set to a float, and a passengers parameter set to a unsigned integer, a U32. And this constructor function will return a flight instance. So here after an arrow, I can either write flight or capital S self, which is the same thing. Similarly, in the body of my function, I can either create an instance like this, or I can use the self keyword. I'm going to go with that approach. And in order to create an instance of flight to return, I need to provide starting values for the fields. And this time around, rather than defining the blueprint as I did here, I'm actually creating a concrete instance. So I need values for these 4 fields. And I'm going to get them from my 4 respective parameters. Now, of course, I can write something like origin : origin, but there is the shorthand syntax available in Rust, which is if you have a name in the program, such as a parameter or a variable that matches the name of a struct field, you can simply write the name once, and Rust will make the association between the struct field and the name that you have that matches it. So our origin parameter and its string will become the value for the origin field in my newly created flight struct instance. All right, that takes care of one. I'm going to do a comma and a line break and then provide my other 3 fields of destination, price, and passengers. And since this is the last line or evaluation in my function, the instance will also serve as the final return value, and that should do it. All right, define a change destination method that accepts a new destination and overwrites the value of the destination field. So right here, I'll declare my change destination method. And in order for it to be a method, I need to get the struct in some form. I can either take ownership over it, and I can also borrow a reference. And with both of those 2 options, I can also either opt for the mutable approach or the immutable approach. So in this scenario, I know that I want to overwrite some data, and generally speaking, I don't want to take ownership because then I either have to return the instance back or I have the risk of completely losing it at the end of the method invocation. So usually, if you're going to be modifying some data, you want to be able to call a method and then call another method on the struct and have that value continue to live in the program and provide value. So for that reason, I'm going to borrow a mutable reference, which will avoid the transfer of ownership, but also give me the permission to modify the destination field. So right here, I'm going to write ampersand mute self. That is going to be a mutable reference to the instance. When I call change destination on my flight instance, we're going to do that in the main function in just a second. We're going to get a mutable reference to that instance right here, represented by the keyword self. Then I'm also going to need the new destination string that is going to overwrite the current destination field. So here I'll define that parameter to be new destination. The name is up to us, and it will be of type string since it is replacing a string. This method will return nothing. And in the body, I can provide self and use my dot syntax to access the current destination field. And using an equal sign, I will overwrite it with the new string provided by the new destination parameter. That is a struct mutation. That modifies some part of the struct's internal data, what we call its internal state, and that is why I need a mutable reference. If I tried to write this, the compiler would say, that's not valid. You can't overwrite something because that would be a mutation. So I'll change this back to mute self. Next up, define a increase price method that raises the value of the price by 20%, multiply the price field, this should be by 1.2, and make sure to save the new price field value. So same principle here, I'll define my method, I'll call it increase price. In order to change some part of the struct's internal state, I need permission to do so, so I need something mutable, and I'm going to borrow a mutable reference with ampersand mute self. This time around, I do not need any new data. I'm simply going to use the current data I have in the price field, multiply it, and then overwrite the value in that same field. So if I take self.price and I multiply it by 1.2, that's going to give me my new price, and I can overwrite it once again by accessing my price field, providing an equal sign, and then the new value is on the right-hand side. If you know your Rust shortcuts, you'll know that you can simplify this to use this operator, the asterisk equals, and then put the value of 1.2 on the right-hand side. So what this means is take the price, multiply it by 1.2, take the result, and assign that product back to self.price. So that should do it. Next up, define an itinerary method. Here we go. And it's going to print out both the origin and the destination fields in the following format, with origin, then an arrow, then destination. So this method is not mutating any state, it's just reading the struct's internal state. So I don't need mutability, but once again, I do not want to take ownership, so I'm going to stick with a immutable reference. And the syntax for that is going to be ampersand self. Once again, self by itself, pardon the pun, would take full ownership, and I don't want to do that. I want to borrow an immutable reference. All right, and for this, I do not need any additional parameters. I do not need any custom return value. And in here, I'm just going to print line, and I need to provide this, then my arrow, then this, and then I need to provide my origin field, and then my destination field, and that should do it. All right, so I think that takes care of all of our required methods and functions. The next step is to use the constructor function, which is new, to create a new flight instance. So I need a main function, and we'll make some room here for ourselves. And let's go ahead and do that. So I'm going to declare a variable called myFlight. I'll refer to my flight struct, and on it, after I use the two colons, the scope resolution operator, I have my new constructor function. Notice that this associated function is being called on the flight type itself. It is not being called on a flight instance. In fact, we're not going to have an instance until this function is done running and gives one back to assign to the myFlight variable. So in order to create an instance, I need 4 parameters, which are going to fill in for the 4 fields. So we can all just substitute arbitrary value here. So for my origin, let's do New York. So I'll do string from to create a string. I also need a string for my destination, and I'll do Los Angeles there. I'm writing these on separate lines just so they're easier to read. I need a price that is a float. Let's do $299.99. And I need a number of passengers, which will be a positive unsigned integer. So I'll do 150. add my semicolon, and now we have our flight struct. All right, so immediately I can use my debug formatting to print out the value of my flight. We derived our debug trait implementation right here. So if we did not do that, this code would not work, but now it will because we have our debug trait implemented. And this is what our flight looks like. And these values match exactly what we expect. So now let's try to invoke our available methods. So for example, we can take my flight and we can try to change its destination. Let's try to take us somewhere else. Let's try to go to a place like San Francisco. Now we're trying to call a method that borrows a mutable reference. The problem is our myFlight variable is not mutable itself. The owner is marked as immutable, and we're not going to be able to call any method that mutates the instance unless the original owner is made immutable as well. So here I'm going to add my mute keyword. So once again, when we call change destination right here, Rust will automatically pass in a mutable reference to myFlight in this scenario. We do not need to create it ourselves. We do not need to write the ampersand mute syntax. It will automatically happen behind the scenes when change destination is called, and the object or value upon which it is called, the instance of myFlight, that's how Rust knows that it is this instance that we want to borrow a mutable reference to pass into change destination. We are still obligated to pass in any follow-up parameters. So for this new destination string, I do have to provide that here to satisfy the compiler. So after we do this, we should have changed the destination field. We're going to validate that in just a moment, but let's also call our other mutation method, which is going to be increase price. That should increase the price by 20%. And then let's also take a look at our itinerary. So I'll invoke itinerary. This is a method that does not mutate, and it takes care of the print line for us. So it should print out our origin and our destination. And since we changed it to San Francisco, we should be going from New York to San Francisco. That is exactly what we get output here. And then if I output my flight in debug format after we increase the price, we should also see the price go up by 20%. So here it is at $299.99. Here it is increased to $359.98. This little bit of rounding here is totally fine. And that's exactly what we expect, a 20% increase. All right, so I think we invoked all of the defined methods, printed out the struct in debug format to confirm the struct is updating as we expect. Finally, we want to use the struct update syntax to copy the price and passengers fields to a new flight struct instance, but make sure to provide new strings for the remaining fields, which are origin and destination. Remember, when we use that double dot syntax, we are going to copy over all of the fields. The problem is the origin and destination fields here are strings. Strings do not implement the copy trait. So unlike floats and unsigned integers, Rust will not make a copy of these strings. Rather, it's simply going to move ownership from the origin and destination fields in myFlight to the origin and destination fields in the new struct that we're going to create. And that's going to create this weird state where myFlight would have ownership over these two values, but not these two values. And that's kind of a weird state, so generally not a good place to be. So how do we avoid that problem? We need to provide concrete values to origin and destination when we create our second instance, or alternatively, when we create it, we can also just call clone on these strings to create full copies of these strings on the heap. And if we have full copies, then we have duplicates, and the respective origin and destination fields in both of our two structs maintain their own copies of the data. So right here, let's declare a variable called another flight. And here I'm going to use my regular instance creation syntax, which is my struct name, then my curly braces. And I need to provide the fields that I want to provide custom values for first, and then we'll use our update syntax with the double dots. So for origin here, let's do a string and do something different like Paris. For our destination, let's do a string of Rome. And for the remaining two fields, price and passengers, I want to copy them over from here. And since these implement the copy trait, Rust will create full copies. So right here, two dots, then myFlight, that is the source from which I want to take the fields from. These fields are going to be copied, so there's no risk to doing so. Once again, this is going to come after any of the fields that you want to provide custom values for, and Rust knows to omit any previously mentioned fields from this copy. So origin and destination will not be included because they are written explicitly before the double dot syntax. Then I'll provide my colon, and let's go ahead and print out another flight right here. And what I'm going to do is add my debug formatting, and I'm also going to pretty print it this time around, so I'll add the hashtag. And just to confirm our assumptions, my expectation is we're going to see an origin of Paris, a destination of Rome, a price of $299.99, and a passenger count of 150 if we did everything correctly. So there we have it. There is our second flight instance, and we have our origin, destination, price, and passengers be what we expect. All right, so that is a quick review of all of the struct concepts that we talked about in this section. Once again, the advantage of a struct is we are able to define a real-world idea, a collection of related data that is grouped together, that is collected together within this larger composite type. And unlike something like a tuple, with a struct, we have the advantage of being able to provide context and clarity on what these pieces of data represent. It's really hard to model the idea of a real-world flight as just a simple float or a simple string, right? It's a complex collection of real-world data that, say, an airline would need to track if they're building a program in Rust to track their operations. So a struct allows us to define new types, often modeled after real-world ideas, that aggregate these collections of values together and then allow us to perform operations to read that data, to overwrite that data, to copy that data to other instances, and so on. So we're getting closer to the ability to use Rust to model real-world constructs, which allows us to also model entire real-world domains. So this is a big, big, big tool in your Rust toolbox, the struct. That's all there is to cover in this lesson, so I will see you in the next one.